until this point, what was the question that we were trying to answer?
The area.
Yes, good. And we started maybe with some simple kind of shapes. Right. If I just had, for example, a straight line, right? I could say, let's look at some bounds, maybe from wherever this is to here, and let's try to find the area underneath the curve, right?
That's not a curve.
Or the line. and this one's pretty cool, it looks like a little triangle, right? But then we moved on to some more complex shapes, because just by using, I guess, our knowledge of geometry, we could have found this anyway. We don't need to use integration. But what did we introduce that I couldn't find very easily? It was these areas underneath curves, right? Do we remember how I actually found the area underneath the curve, under a complex shape like this? What did I actually have to do? Sorry? I had bounds.
Integrate it.
I did integrate it, but what did I have to do to actually find the area underneath the curve? What did I have to do? How did I break it down?
Yeah, rectangle.
With the rectangle. I had like little rectangles. And the smaller and smaller these rectangles got,
The more accurate.
yes, the more accurate I got. Okay.
More accurate.
But what I'm going to introduce to you is this is kind of like Transformers, right? There's more than meets the eye with these areas.
Whoa.
Initially, you know, you just saw a boring line. And then we introduced an area underneath the curve. But then I want to think, just with this area, how can I introduce a volume? How can I introduce a volume? And I'm thinking, okay, let's try and transport ourselves into this Cartesian plane. So like, yeah, so kind of like when you go into Jumanji. Have you seen that movie, Jumanji? Yeah, you're going into the void. This one's even better. You get to go into the Cartesian plane here. Okay. I'm going to go into the Cartesian plane. Imagine this is the area, this is the axis I've got, and this is the area under the curve here. I've got this kind of triangle, right? Yeah. If I wanted to think, how could I make this into a volume, a 3D shape? What if I took my area and I rotated it around the axis? Right?
Boom,
You can start to see, hang on, I could start to create a 3D shape. If I make go this faster and faster, can you see what kind of shape I'm creating with this?
Oh,
a cone.
Okay,
Make
right.
a triangle.
So if you look at the face on, maybe if we've got a triangle here, and I was rotating it around and around and around, and faster and faster I go, you can start to see that shape that's forming.
It's a bigger triangle.
I heard it
It's a
before.
cone.
Yeah, it's a cone. It's a cone. That's pretty cool, right?
Yeah.
Pretty cool. What's cooler is this guy.
Oh no.
What if I rotated this thing around?
Parabola.
What would I get?
3D parabola.
Parabola.
I'd get something, I don't even know.
It's like a pyramid.
Yeah, it'd be like a pyramid. It'd be sort of like a pyramid. See, this one has a tip though, right? Because it was a cone.
Yeah, the other one just stops and flat.
Yeah, this one's just flat.
How many cones did you make, sir?
So you agree that you can see that circular shape on the base of the cone, right? If you rotate it around. The same thing here. If I'm rotating this curve around, right, I'm going to get a circular shape. But we don't actually have to imagine it, right? I can actually take this guy, and with the magic of technology, we can actually see how a 2D shape turns into
an umbrella.
a 3D one, right?
It looks like a black hole.
It looks really interesting. I don't know if it looks. I've never seen a black hole, so I wouldn't know. I have seen Interstellar though, so I don't know if it's the same thing. I don't know what this shape. It looks like almost a tree stump, right? But you can see how
Definitely not a tree stump.
we started from just a simple curve, finding the area underneath, and then when I rotate it around the x-axis, I can create this volume. Okay, this kind of shape here, right? Can you guys visualize how that's actually happening?
Yeah.
Is this making
Yes,
sense?
that is helping.
Yeah, okay. What our challenge is how do we actually find that volume? How do we actually find that volume?